the nucleus, they found quarks, which are indivisible particles. And there's 6 kinds of quark: an up quark, a down quark, a charm quark, a strange quark, top quark and the bottom quark. And there are 6 kinds of leptons, which is one of which is an electron, a tau, a muon, and the 3 neutrino variations. Those 12 particles make up everything in the universe. The piano, the stage, the air we breathe, and my eyebrows, in fact. Interestingly enough, there are 12 notes on the piano. And every song, certainly in the western part of the universe, is made of those 12 different notes combined in a different order. And yet we have almost a seemingly infinite different number of melodies and musical motifs. The 4 fundamental forces of nature push those 12 fundamental particles together to create the universe we know. The first force is the electromagnetic force, which is light, radiation, radio waves, electricity and magnetism. The second one is the strong nuclear force, which binds the atom together and stops it spinning off into space. The third is the weak nuclear force, which allows radioactive decay in the heart of very hot stars to create the matter that makes up the universe. And the final one is gravity. Yet no one has managed to prove the existence of gravity scientifically. We know its effect, but we are still looking for either gravity waves or gravitons, the particles or the waves that will be associated with gravity, and we can't find it. In fact, Einstein's general theory of relativity, which describes gravity as a part of the space-time continuum, or an effect of the space-time continuum, is at odds with quantum mechanics. The two don't fit together, and that really annoyed Einstein, and it really messed up the quantum mechanic engineers, who've spent the rest of eternity since the beginning of the last century trying to create one grandly defined, unified theory of everything. In the midst of that, they discovered that particles that do have mass shouldn't have mass, because the maths don't work. So where does the maths come from? Well, Peter Higgs, who was a Scottish physicist at the beginning of the 60s, came up with a very interesting proposal. He said during the Big Bang, a special field was created, and that permeated the entire universe. And as particles pass through it, depending on their size, their shape, and their spin, they attract mass. Still with me? Yes. Okay, I can see I've lost a few, so I'll give you a quick visual analogy. Imagine a ping pong ball on a piece of string. After a few seconds, if you were to close your eyes, it would feel that the ping pong ball was weightless. But if you put it at the bottom of a bucket of deep, thick treacle, and you slowly lift it up, it would feel heavy. It's not really heavy, it's the treacle holding it back. And that's in a theoretical version of what the Higgs field does throughout the universe to particles as they pass through it. And if the bigger ones attract more mass, and the smaller ones attract less mass. Does that make some kind of sense? Okay, the only problem is we cannot measure the Higgs field because it is as big as the universe. But if we can find the Higgs boson, which is a particle that's associated with the Higgs field mathematically, then we know that that's where mass comes from. Otherwise, we don't know why particles have mass. That's the scientific reasoning behind it. And by trying to create energy that replicates the beginning of the universe at the Large Hadron Collider, we're trying to see if we can create a Higgs boson just for a few seconds and measure its existence. That's what we're looking for. So I thought I'd write a song about that. The song is actually shorter than the introduction, but everything I've just told you is in the song, so I just wanted you to be aware. It goes by very quickly, it's 2 minutes and 40 seconds. It's called The Search for Universal Truth. There are only 12 particles, the fundamental articles the universe is made of at its heart. Nature likes to rearrange her charm, and something that's quite strange from top to bottom, up or down, and that's the quark. With leptons like electrons, tauons, muons, and 3 more neutrino variations, making up the final scope. But then there is some more. It's the bosons that are mediating particles that are creating forces nuclear but strong and weak. The neutrons in the proton with the gamma and the sequence and the decaying as we speak. The photons are a wave of particles and all this is to make electromagnetism such a force we can't resist. But mathematicians make predictions contrary to real conditions, and the master formula, mass can't exist. And that's a problem. So the scientists began to think of every single causal link that might explain the missing mass they sought. But Peter Higgs proposed more photos and then exposed none of the problems that the Standard Model brought. A special field created when the Big Bang interface that permeated everywhere and gave the particles their mass. Like trick the liquid slowed to spread depending on the state they're in, and made the universe we know it last. And that's a good thing. Now the Large Hadron Collider is a chance to look inside a world the human eye has never ever seen. By smashing protons fast together, scientists determined whether Higgs was right and what that all might mean. But the world must hold its breath until the experts can reveal if his theory is correct and thus Higgs boson is quite real. Then that would be I. The granted unified theory still defined quantum queries as we search for gravity in tiny waves. But Einstein was annoyed that relativity is not employed when the mechanics of the quanta are displayed. So the search continues day and night to find a formula to write that can deliver what we hope's the final proof. Joining everything together, one equation for forever, giving us the universal truth.